Hi guys, Mr. Davis here. This is the mark scheme that we're going to go through for our recent test on the neuromuscular system and the musculoskeletal system. Occasionally I might write a few things down, but for the main part of this, I'm just going to talk you through the answers. So pay attention, pause it whenever you feel is necessary at the end of each question to either tick off your correct answers, I hope, or to note down any corrections that you need to do for any of the questions. Okay, so make sure you've got a purple pen ready and away we go. So for the first one, which of these characteristics which of these are characteristics of type 1 muscle fibers? 4 options there, and the correct answer is A, high resistance to fatigue and a high number of mitochondria. That would be type 1 muscle fibers. Okay, change the color of my pen. Okay, yeah. Which part of the nervous system is something referred to as a fight or flight response? And the answer to that one is the sympathetic nervous system. Sympathetic nervous system. Number 3, which muscle fibers are often referred to as fog muscle fibers? The answer to that one is type 2A. Full name is fast oxidative glycolytic. Fast oxidative glycolytic, hence the name fog. Number 4, which muscle fibers are often referred to as slow twitch muscle fibers? And that is type 1 muscle fibers, which are slow oxidative. Number 5, which muscle fibers are quick to fatigue or quickest to fatigue? And that is type 2X, type 2X, fast glycolytic. Number 6, which muscle fibers are the slowest to contract? That is type 1, it's the slowest of the 3 to contract. Number 7, which muscle fibers would be best suited to an athlete performing in the 100 meters? That is type 2X again. So the FG muscle fibers. Number 8, which of the following is not a structural feature of, which of the following is not a structural feature of muscle fibers? And that one is anaerobic capacity. Yeah, that's not a structural feature. So what must it be? That's functional. So that's one of the functional characteristics. Number 9, which muscle fiber would have a medium aerobic capacity? And that is type 2A. And number 10, which muscle fiber produces the greatest force? And that is type 2X. So just pause there, make sure you've got all of the corrections that you need to. If that is a topic that you've struggled with, please go back to the first of our lessons on the neuromuscular system. There's a table towards the end of the presentation which details lots of information about the characteristics of the different muscle fibers, and that is something that you will need to familiarize yourself with. Moving on. So we then moved on to looking at recruiting muscle fibers. So the part of the motor neuron labeled A on the diagram, a couple of different names. You could have had motor end plate or the neuromuscular junction, but it's those kind of weird feet-like parts of the motor neuron. So the motor end plate or the neuromuscular junction. Number 2, the name of the tiny gap which exists between the end of the nerve and the muscle fiber. And that is the synaptic cleft. Synaptic cleft. Number 3, identify an alternative name for the impulse. That is the action potential. So more often than not, it would say impulse in the exam question, but you need to be aware of that alternative name just in case, so you don't get confused. Number 4, the name of the substance which must be present for the impulse to pass into the muscle fibers. So that substance is what is known as a neurotransmitter, and the proper name for it is acetylcholine. Acetylcholine. It's a neurotransmitter. Essentially, it helps pass the impulse across the synaptic cleft. Number 5, key features of the all or none law. So there's 3 things really that we're looking for here. Number 1, or in no particular order, but number 1 that I've got, so all of the muscle fibers contract or none of them contract. So it's not a case that there's a half of a contraction or some of the muscle fibers contract and others don't. When there's an impulse sent down the neuron, they either all contract or none of them contract. That would be the first one. Second mark for saying, so there's no partial contraction. So it's either all of them or none of them. That's the first mark. There's no partial contraction. That's the second one. And then the third one would be for saying that the stimulus must pass a threshold. So there's a particular point which the stimulus must reach. If it doesn't reach that point, then there won't be a contraction, and then none of the muscle fibers will contract. Okay, number 6. The process which involves impulses being sent quickly and repeatedly to the same muscle fibers, and that is wave summation. Wave summation. Number 7, identify the process which involves impulses being sent to alternate muscle fibers so they share the workload, and that is spatial summation. Number 8, in addition to the processes identified in question 4, 5, and 6, one other method of adjusting the strength of muscular contractions, and that is the selection of either slow twitch muscle fibers or fast twitch muscle fibers, or slow twitch motor neurons, fast twitch motor neurons. So by adjusting that will dictate whether there's going to be what kind of contraction is going to be taking place. Okay, then we move on to PNF. So it wasn't a question on there, but can we remember what PNF means? Oh, if you don't know, then you will have struggled with this. Okay, so number 1, 3 stages of PNF. So the first stage is a passive stretch. Passive stretch with the support of a partner. So that's key. That's in the first phase. So your partner will gently lean in and you will just let that muscle stretch out. Second part of it is that the athlete pushes back. So there's a gentle pushing back, but there's no movement because your partner will be holding a resistance against it. So essentially, it's an isometric contraction, but we'll come to that in a minute. So first stage, passive stretch with the support of the partner pushing against you. The second phase is where you push against them. It's an isometric contraction, so there's no movement. And the third phase is that your partner will reapply the pressure to increase the stretch again. So it goes one way, and you push against it the other way, but without any movement. And then your partner pushes back again. So it's 3 phases. Number 2, one of the 2 pieces of information is detected by the muscle spindles. So you could have either had how far the muscle is being stretched or how fast the muscle is being stretched. How far and how fast. Number 3, the name of the information sent from the muscle spindles to the central nervous system. That is excitatory signals. Excitatory signals. Clues in the name. Excitatory signals. Number 4, the name of the process which is triggered by the central nervous system telling the muscle spindles to contract. That is a stretch reflex. Okay, number 5, what type of contraction takes place during the second stage of PNF? That is, as mentioned previously, the isometric contraction. So muscles are working, but there's no change in length, no movement. It's isometric. Number 6, the information detected by the Golgi tendon organs is the tension in the muscle. T for tendon, T for tensions, tension in the muscle. And number 7, the impact the Golgi tendon organs have on the muscles during this process. So there's a couple of key bits of information here. So there's an inhibitory signal sent to the brain, which overrides the signal from the muscle spindles. That then causes the muscle to relax. So it's having had that initial stretch, and then the stretch reflex occurs where the muscle spindles are saying, okay, yeah, we don't like this, we need to do something about it. There's then this isometric contraction that takes place. It's tension in the muscles, even though it's an isometric contraction. The Golgi tendon organs detect this tension, and they send this inhibitory signal to the brain, which overrides the signals from the muscle spindles. And because it's overriding that initial signal to say there's too much of a stretch taking place, there's then a relaxation of that muscle, and then when you push back against it, when your partner pushes again, the stretch can be increased. So just to be clear, so it's an inhibitory signal sent to the brain that overrides the signals from the muscle spindles. Muscle will then relax. And finally, the section on the movement analysis. So number one, the articulating bones involved in the joint action taking place at the knee. That's the tibia and the femur. Hyperextension is the increase in angle at a joint beyond 180 degrees. So extension is just an increase in angle at joint. Hyperextension, increase in angle at a joint beyond 180 degrees. Number three, the definition of horizontal abduction. So that is movement of a limb forward while it's held parallel to the ground. Movement of a limb forward while it's held parallel to the ground. So if you have your hands up and out to the side, and then you bring them across, pointing out in front of you, that movement is what is called horizontal adduction. If it's going the other way, so you start with your hands up and out in front of you, and then you pull them back to the side, that is horizontal abduction. Number four, the planar axis involved when a gymnast performs a cartwheel. So think of the direction of the movement. Direction of the movement sideways. Sideways is the second of the pairs in the rhyme. So silly teachers force students. So the F, frontal plane, S, sagittal axes. Number five, which axis is paired with a transverse plane? Transverse plane. So the plane is always the first one in the pair. So silly teachers force students to, so that's the transverse plane, learn longitudinal axes. So the axis which is paired with the transverse plane is the longitudinal axes. Number six, one of the joint actions possible at the ankle joint. You should have had plantar flexion or dorsiflexion. Number seven, the joint action taking place at the shoulder between image A and B, or from image A to B, that should really say. And that is horizontal. What have I got down here? From A to B, horizontal abduction. So it's moving the limb backwards while it's held parallel to the ground. If it was going the other way, it was going from B to A, that would be horizontal adduction. Horizontal abduction is coming the other way. Number eight, the role of the antagonist in antagonistic muscle contraction is that it works in opposition. So we don't really want to be saying relaxers, even though that's kind of what's happening. We're saying it works in opposition to control and coordinate the movement. Number nine, the difference between concentric and eccentric. Concentric, its muscles will get shorter in length. Eccentric, its muscles will get increase in length. Number 10, the alternative name for the agonist is the prime mover. Number 11, the agonist during flexion at the hip. Sorry, the antagonist during flexion at the hip. So the agonist during flexion at the hip flexors. Antagonist, therefore, will be the gluteals. Number 12, the agonist during adduction at the hip. So think of what that movement looks like. And that is that one called your T, F, L. Which one? Which question were we just looking at? This one? No, this one, sorry. So the agonist during adduction at the hip is your TFL, which is your tensor fasciae latae. Hopefully you've got that. Tensor fascia latae. Number 13, the antagonist during flexion at the shoulder. So think of what that movement is. Flexion at the shoulder. So bringing that arm up in front of you in order for that to happen. Have I got antagonist? Yeah, so antagonist. So the ones that are working, so your deltoids. So the antagonist, your latissimus dorsi. Yeah, when I said deltoids, it should be your anterior deltoids. So anterior is the front. Put your hand on your shoulder, bring your hand up out in front of you. So your anterior deltoids working. The ones that are working in opposition to that are your latissimus dorsi. 15, the type of contraction which takes place when performing a plank is an isometric contraction. No change in muscle length, no movement. 16, joint action which occurs at the knee during the downward phase of a squat, and that is an eccentric contraction. Joint action which occurs at the knee during the squat. Yeah, so that's flexion, which is the joint action. The type of contraction is eccentric. The joint action is flexion. And finally, the agonist. The agonist during flexion phase of a press up. So think of what that movement looks like. So bending your arms, decreasing angle at the joints. You're on the way down from a press up. And the agonist there are your triceps. So normally during flexion at the elbow, it would be your biceps, but because it's a controlled downward movement, that's eccentric. So it's the opposite of what you'd normally associate with that movement. It's the agonist during flexion phase of the press up are the triceps. They are working eccentrically. Okay, what I'd like you to do is total up your marks for each section. The overall mark was out of 50. So if you could mark it all up, put a mark and a percentage at the top of your paper. Like this. And then send that to me, show me all of your work from today marked. I will also add a video that I'd like you to watch. I'll put the link to it on Show My Homework, and that will just set us up nicely for Thursday's lesson. Okay, guys, hope that went well. Enjoy the rest of the day. Bye-bye.